Hello everyone, today we present our group project which will be about dog image retrieval with few-shot learning. So in our project, we will be using few-shot learning in the classification task that we will use it to classify dogs that have few image data and also new image data. Using few-shot learning allows for faster classification when compared to the normal classification models. So what is few-shot? Few-shot learning is a machine learning framework that allows a pre-trained model to generalize to new category. Using only a few level samples per class, it found the meta-learning, which means learning to learn. Like human can identify new object with minimal example using prior knowledge. Few-shot learning will try to mimic these abilities. So for how the few-shot work, we will have a support set which will include the categories of animal, which in here we have penguin, pelican, and puffin. And we will have query image to ask the model to do the prediction. With the prediction will come in the similarity score. As you can see, the model prediction was penguin with a similarity score of 0.71, which are the highest. For our group objective, we will be compare various few-shot learning models to enhance the performance and accuracy in the model prediction, and to evaluate the accuracy of causal similarity and k-nearest neighbor to know the pros and cons of this approach. We will also create a convolutional neural network model tailored specifically for a task at hand, and to implement the pre-trained and inception V3 model to perform the same task as the Siamese network. After all the development, we will be comparing performance of these three models to know which is the most effective. Okay, for the methods. For our work step, we first be gathering data for training models and few-shot learning tasks. Next, we train Siamese network, CNN, and Inception V3. Then we use feature extractor to do the few-shot learning task, then do the few-shot prediction task for Siamese. We use KNN and causal similarity. For CNN, we will be using only causal similarity to do few-shot prediction tasks. Last step is to compare the result of all the model, which one is the best in each scenarios. Okay, for the Siamese model, Siamese networks are neural architecture with identical subnetworks sharing the same parameter and weight applied to different inputs. They are useful for tasks involving similarity detection. In this project, Siamese network compare a given dog image to know dog image to determine the similarities. Next, for the custom CNN, we define a convolutional neural network in PyTorch for image classification. It has five convolutional layers with ReLU activation, batch normalization on 4 layers, and max pooling to reduce feature dimension. The input size to fully connect layers is dynamically determined using a dummy forward pass with 0 tensors, allowing neighbor to adapt to different image size. The network ends with a fully connected layer that maps features to the specified numbers of classes. Using cross entropy loss for training, this setup makes the convolutional neural network versatile for various image classification tasks with adjustable input size and class number. Next, for the Inception V3 is a convolutional neural network designed for image analysis and object detection. Inception V3 allows for deeper network without a significant increase in parameter. Often pre-trained on ImageNet, it has been widely used in various applications, including leukemia research in life science. And it is for our training time with Siamese of 11 hours, Inception of 1.16 hours, and lastly CNN for 0.33 hours. And this is our comparisons of all the result comparison of when we plot all of the accuracy into a graph. You can see from the graph that KNN are not suitable for one shot compared to another models, but perform comparable when working with 3 shot or higher. And therefore for Siam it work best in one shot, but if we have support set with higher than 3, we can use another model because of training time consumption advantage. Thank you for your attention.